Hi there, class. It's me, Mr. H. We're going to do the last page of 8.2. This is page 4, continuing with law of cosines. We have another word problem. This one is going back to that bearing from way back in chapter 5, I think we did. Starting at a point A, the key on this one is getting the picture right, because there's a little geometry involved. So a ship sails on a bearing of 187 degrees. So let's just stop there and see if we can get that. So what I like to do on these is draw a compass, like north, south, east, west kind of thing. So where this is due north right here, right? And if you're going 187 degrees, remember bearing is always measured clockwise from due north. So 187 would be 7 degrees past that 180. 180 is due south. So that route would be, if I kind of zoom in, something like this, right? Where this angle in here is 7 degrees. Okay, that would be a 187. This would be 187 right there. Okay, take that out so it doesn't, it's a little distracting, but that's the bearing of 187. So that distance is 18.5 kilometers. Okay, then at that point, turns and sails on a different bearing of 318. So when the ship reaches this point right here, it makes a turn and goes at a bearing of 318. So what I'm going to do is draw a new compass on that point right there. So let's draw a new compass on that point right there. Okay. So, or again, that's due north, south, east, west. And then so at bearing of 318, again, clockwise from north, 0 degrees is north. So 270 would be here, right? And so that would be 48 degrees past 270, because 48 plus 270 is 318. So that would be something like this. It's going to go kind of far, right? That one is 47.9 kilometers, right? So I'm going to kind of make this all, it's much to scale. Wow, that's really awful. Let's just try this. Ooh, that was a little squiggly. Oh, got some rough C's going there. All right. And so again, if I label this, that was 48 degrees there, right? Notice 270 plus 48, that's that 318. So that bearing was that, right? That's 318. Okay. Okay. And then the question is, find the distance the ship is from point A. Remember, point A was here. So I'm trying to find, let's put that in red or something. Oops. The distance back to point A. That's what I need to find right there. Okay, so I got a little geometry to do to figure out some angles. One thing, notice I have two parallel sides. Let's do some highlighting. This and this are parallel, right? And then you have this line going between them. That's alternate interior angles are equal, right? So if that's 7 degrees, then this angle in here is also 7 degrees, okay? Let's remove those highlights. We got that, okay. How about this angle here? Whoops, didn't want to erase that. How about this angle here? So that's a 90-degree angle. So if this is 48, then inside there would have to be 90 minus 48 or 42. All right. And then now I have an angle inside the triangle there, right? 42 plus 7, 49 degrees. Okay. Now notice you have side angle side, because we know this distance, right, is 18.5. This longer distance, that one, was 47.9. It's hard to write that 18.5, but I'll sneak it in there. So I have side, angle, side, right? Again, side, angle, side, okay? So that's law of cosines. Anytime you have side, angle, side, start with that side that's unknown, the x, and it's squared. That should equal each of the sides squared, added together, almost like the Pythagorean theorem. But then you gotta keep going. Minus 2 times each of those. Times the cosine of the angle, which we found to be 49 degrees. The hardest part of this problem is getting that 49, because that was all with the picture and geometry and alternate interior angles and adding up to 90 and drawing the picture right and bearing and okay. But once you have this all set, then the calculation is fairly straightforward, right? This is, if I calculate all that, this is I'm getting 147 point or 1,473 point, I don't know, 926,583. Okay, and then take the square root of that, round to the nearest tenth. That's 38.4 kilometers. Okay. Hopefully that's right. That looks good. Okay. Okay, one more type of problem for this section is what's called Heron's formula. It's for area if you have the side, side, side case. So the derivation of this formula, again, you can find in the textbook. I don't cover it in this video. It's not required, but if you're interested, check it out in the textbook. And you'll see the derivation of this formula, which is pretty cool. But basically it has to do with the semi-perimeter, which is half of all the sides added together. And then you get this area formula here. So let's just try to apply it. The first thing you got to do is find the semi-perimeter. So in this case, it's half of all of the sides added together, A 2451 plus B plus C. Okay. So if you've calculated that, add them all up and basically cut it in half, you're going to get 2604.5. So there's your first step, find that semi-perimeter. Now plug into that area formula. So my little fancy A for area, square root of a lot of stuff. So I got to put in the S. And then it's S minus A. In parentheses, and then S minus B in parentheses, and then S minus C in parentheses. Okay, and that's it. Now you just gotta, you could probably put all that at once into your calculator if you wanted to, or you can do an intermediate calculation, just get all that subtraction first. Right. So I'll just write that. Can I write that a little nicer? Jeez. Oof. So I try to write nice and I start messing up. Okay, so I'm just calculating these out. This is not too exciting. And then put all that in your calculator, round to the appropriate nearest. This is really big. 401,664 square miles will be the area of that triangular region to the nearest square mile. Okay, square miles because it's area, so you gotta put double square on there. And that is that. So okay, hope that helps. That's the end of 8.2. Hang in there and send questions my way if you have any. Okay. Talk to you later. Bye.